thank you very much for that, and it was remiss of me to not introduce Maureen, who is the chair of the Sustainability Membership Council. To introduce our next speaker, I have Mr. Arturo Echeverria, who's an ICC member from Mexico City and a representative of the insulation industry.
Good morning. I have the honor to be presenting a person that has been chairman of so many committees that I feel humble with him. I'm going to introduce Mr. Wayne Trusty, president of Wayne B. Trusty and Associates. He has more than 40 years consulting experience in a wide spectrum of subjects, including the environment, resource economics, water resource, transportation, energy policy, and regional development. He has an adjunct associate professor category at the University of Calgary, Faculty of Environment and Design, a former member of the board of the Green Building Initiative, and served as chair of the technical committee established in the U.S. to take the Green Globes rating system through an American National Standards Institute update process. He is chair of the ASTM working group that developed a standard of practice for whole building life cycle analysis and worked as a consultant on various aspects of the environment product declarations, EPDs. He has participated in a number of committees, provides education on life cycle analysis, environmental product declarations, and is a frequent speaker on these two subjects at sustainable infrastructure and building conferences. Wayne, thank you.
Thank you, Arturo. Who is this guy? I had to change to my own Mac computer because otherwise Steve Jobs might haunt me a bit, so we had to make a change. All right, so let me ask come on, machine. Let me ask a quick question, if I may. How many people here are not familiar with life cycle assessment? Do we have a few? We have no one, so everybody understands life cycle assessment. Oh, no, okay. All right, well, and I'm going to move quickly through that part of this. So let me just get it rolling here. Whoops, darn it. Okay. All right, so the word analysis in this subject, I am going to be focusing on the life cycle assessment of whole buildings, not other kinds of analysis, because there's lots of other analysis, like economic cost analysis. But this focus is on the life cycle assessment side. And I won't spend a lot of time on this because you folks are well familiar with what life cycle assessment is and tracing all these effects, materials, energy, releases to air, water, and so on. So I won't spend time on that. All right, now whole building life cycle assessment is included in a lot of different codes and standards. And these are just North American examples, okay? So I'm not really up on what's happening elsewhere in the world. You know, in some cases, the UK and so on, but these are just some North American examples. And if we look at the IGCC, the International Green Construction Code, the position there is that you do a life cycle assessment of a reference building and the final design using the same tools for both assessments, and I'll get into explaining the tools in a few minutes that are relevant here, and demonstrate at least a 20% improvement of 2 out of, I think it's 5 measures that are stated in the standard. And it's a mandatory position in terms of 20% and demonstrating that. So that's one example that's very tied to the codes. In the LEED system, in the Green Globe system, you get points if you have demonstrated improvement. In the case of LEED, you've got to demonstrate a certain percentage improvement in I forget how many, but several measures, and you can't have a reduction in more than 2 measures by a certain percentage. So those kinds of things are being built in to make this an important part of the process of sustainable building. So I won't go through the others here, but I wanted to give some sense of this. Now, at the building level, it's important to kind of understand a bit of the terminology. So here we have a building, cradle-to-gate manufacturing of the products. They're then transported and on-site construction occurs. Operations and maintenance has impacts throughout the life of the building. And then there is the final end-of-life stage where products are disposed of. And the terminology that's used, and it gets confusing for people sometimes, is that in that cradle-to-gate stage and on-site construction, the term that's used in initial embodied effects. Now, I've never personally liked the word embodied. I'm not sure where it came from, because it implies that it's right there in the product and you can somehow get it back out, which is not the case. Yeah, you can burn some wood and get the energy back, but it's a tricky term. But nevertheless, that is the term that's used. Then during the use stage, recurring embodied, plus the operating energy. So that can be brought in to the tools, and in the IGCC it is required. But it's up to the specific code or standard whether operating energy gets brought in and is required or not. Okay? So that's very important. When operating energy comes in, and I think it's a good thing when it does, there can be some balance and consideration going on about the materials that have been used and their impacts, and then what are the implications for operating energy, which is very important, obviously, for buildings, as everyone here knows. So that's a very important aspect to bring operating energy in. And then at the end of life, the term that's used there is final embodied effects. Okay? So that's just some terminology that keeps coming up, and sometimes I've found in conferences and discussions it creates confusion, so it's important to have these terms in mind. So when we're doing what is referred to as the inventory step for a product, and those, you all seem pretty familiar with LCA, so as you know, that's getting the raw data for all of the building materials, okay, and that's the inventory step, getting that data. Then we have, and so there's the material acquisition stage, building construction then, and what goes on there, and for any given product, if there are what are referred to as ancillary materials required for its installation, then those have to be taken into account at the construction stage. So that can be fasteners, it can be glues, it can be a variety of things, and those should be taken into account. Then occupancy, reuse, use, reuse, maintenance. And one important thing that comes up, and it's very critical, is any product has a reference service life. How long will it function before it has to be replaced? And that will very often, maybe even typically, I could say for most products, be much less than the life of the building. Now, the life of the building isn't always known when you start. So there is an assumed building service life that's in the standards. 60 years is very typical internationally, to use 60 years as the assumed building service life. Now, for every material, if it's not going to last 60 years or longer, the replacement has to be taken into account. And when you take in the replacement, you're going right back to the acquisition and building construction stages, and all those impacts come back in. And it's very important. That can play a critical role in the choice of materials that are being used, this replacement side. And then finally, we have demolition and disposal. How is are the products being processed, recycling, reuse, waste management? Those are all things that get taken into account then at the end of building life and the end of the individual product life when they have to be replaced. Okay? Now, as we go through this then, we've got the inventory flows coming in, materials, energy, water, etc., and then emissions to air, water, and land. Okay, so that's the process. One point I want to make here that I think is very important, because we see a lot of debate about this, is what, you know, how good is this? How certain is it, etc. So I want to touch on this. So we have the inventory. It would be great if we could get down to the point where we're measuring the ultimate impacts on human and ecosystem health. That's where we'd love to be. The reality is we really can't get there. And I'm not sure we'll ever get there for a variety of reasons out there. So what we are doing is what are referred to as midpoint impact indicators. So we have the typical set right now: global warming potential, ozone depletion potential, and so on, fossil fuel use, then all the material resource use, and water use. That word potential is the critical one in terms of getting to that final answer that we'd love to be at. Yes, we can measure how much CO2 is being released, but not all that CO2 goes up there. Gets into the oceans. Some of it's absorbed by growing trees and so on. So we can't nail down for a given product, and that's what I'm talking about. I'm not talking about climate change research here. I'm talking about a given product. We can't nail down precisely what the effect of CO2 releases, as an example, are going to be. So that's where that word potential is used. And what we're really measuring is the emissions that can have a global warming effect, but we're not getting right down and nailing it so we know the bottom line for every single product that comes up. Okay? All right, let's just talk then for a moment about the tools that are out there. And this is just a sample of the tools. The key point, before I talk about any of the tools, the key point is these are tools for the design team to use, not having to go get some LCA practitioner to do it. These are tools where the design team can use them, and there is a growing tendency. I'm not sure every tool, because I don't know them all, and unfortunately I don't know even what tools are being used in Asia, for example, Korea, Japan, wherever. But what was I going to say? This is a problem of being too old. Anyway, oh yeah. So some of these tools, like the Tally tool here, the Athena Impact Estimator, they are linked or can be linked to a building information modeling system. So what you're able to do is bring into the tool the materials that are being used for this building, and then the data is all in the tool, the calculations can proceed. In the Athena tool, which the one I'm most familiar with, the Athena tool, you can bring in that data from the building information modeling, and you can do up to 5 design comparisons at a time. So you can, do one and then say, well, what if we change from concrete to steel here, or from steel to wood, and that you can have your second version, and so on, up to 5 versions, which is pretty good. And then you can delete one and go somewhere else. And I know of buildings, for example, where one building that required concrete columns because it was a chemistry building at a university. Typical design process would be to have concrete beams because, concrete columns and beams. So the team looking at this using that Athena tool, they said, what if we put, I think they used glue lamp beams instead of concrete? Well, the impacts dropped. Another building just outside Toronto, They reduced impacts simply by changing the bay sizes. So there was less column and beams, fewer column and beam systems. And that had a bearing. It had a bearing on the concrete foundations and so on. So all of these kinds of factors could be brought into play. The tally tool, which is used, that actually is directly connected as an app for the Revit building information modeling tool. And Revit were involved, Autodesk were involved in its development along with other organizations. So LCAID is one that, let me just make sure I say it, oh darn it. Come on. Oh, sorry. What did I do? All right, well, I won't go there. Picking the right tool is really critical, obviously. You want fair comparisons, no question about that. So you want tools that really are going to do the job. What design stage are you really looking at? Because you don't have to do a whole building if you want. You can be using this at various stages in the design to make decisions along the way. What type of data? Very important. Some LCA practitioner tools have data that has a fairly high European content. Others, much more North American, for example. And I won't get into which tools, but these are tools that the LCA practitioners use to develop these, the basic data that goes then into these models. It's just something to pay attention to. And obviously you can't have a tool that's using a lot of North American data and then take it to some other part of the world and expect it to do exactly the same job. It's not gonna be fair to do that. So these are very important questions to take into account. Now, how am I doing on timing? Okay. There is now a standard under ASTM International. It's designated E2921-16. I think it's supposed to have been, this most recent review, 16A, is supposed to have been published today. It's been in the publication process at any event. So, and it is a standard practice for setting minimum criteria. And basically for a whole building assessment, whether it's in a code, a standard, or a rating system, keeping the playing field level. That's what it's doing. So you don't want a design team to cheat, put an underground parking garage in the reference building and take it out in the final design. No. And this standard, it's a standard practice, is intended to prevent that. So it supports the use of whole system, building LCA and codes and standards, and then ensure very comparative, fair assessments. Building features, life cycle stages, service life, and so on. So that's an important standard if you're doing this kind of work, to make sure you adhere to it. Now let me just talk quickly on whole buildings, on existing buildings. It's very important here with an existing building, and you're deciding, as is very common, do we tear it down and build new on this site, or do we bring it up to date and modify it as necessary? And at an earlier stage, I found a lot of people thinking they somehow had to know what the environmental effects of the materials in that original building were. Well, no. I mean, those materials may have been drawn by horse and buggy to the construction site. It's totally different. What we are looking at is what can we avoid as impacts by modifying the building, bringing it more up to date versus building new. And I think it's very important. And I've been involved in some studies where it turns out it's much better to modify the building than it is to tear it down and build new, from various perspectives, including operating energy because of the thickness of the opaque walls, the number of windows compared to a modern building where you run into different operating energy issues and so on. So, last point I'd like to make is there are limitations to life cycle assessment, and it's very important to keep that in mind. Well, one thing is it doesn't readily handle the issues listed here: indoor air quality, biodiversity, toxic releases, and so on. That is not part of LCA. And we have to, when we're doing this work, think about a toolkit. Don't expect one tool to do everything. And this comes up a lot, I find, with people saying, well, LCA doesn't have biodiversity in it. Well, there is no tool for actually measuring the biodiversity at this point in a way that we can bring it into LCA. So we have to be very careful about that. Okay, so final slide. LCA, as I think most of you know, lets you take the environment into account throughout the project process, focus on the true environmental performance measures, which I think is very critical, and look at the entire life cycle of a building, not just bits and pieces. Make functionally equivalent material comparisons, recognize and take account of environmental and economic trade-offs, because I can do an economic life cycle cost analysis side by side with the LCA and see, okay, what are the trade-offs here? I'm improving this, but I'm increasing the cost, or sometimes it goes the reverse direction even. And then sound decisions and to keep or demolish existing buildings. So final caution that I always make is be wary of simplistic answers to what are very complex questions. So there we go. Thank you.
Wayne, thank you for giving us your talk and giving in simple terms what's really very complicated. And coming from Mexico and getting into these subjects, it took me several years to really understand. So thank you for being simplistic in a way. Do we have any questions?
You had mentioned about some of the LCA software products that are out there right now. Have you noticed that there's been a trend to keep up to date on the newest standards that are being used within the sustainability programs, IECC curriculums, and so forth?
Well, I mean, that's, I'm not sure exactly what the question is. So we've got tools that a practitioner uses. In the Abby, SEMA Pro, or who they come to use one. What are you asking?
Well, my question is, are these software tools keeping up to date with the standards that are being called out in these sustainable programs like Enterprise, the IGCC? Are they keeping up to date with what the latest standards that they're acknowledging and that it must?
Well, that's a design capability part. So we're talking about open codes, for example. That's the design. That does affect things that are done. Now, if something new is coming in that has a product implication, and has an impact implication, I would say to try to keep up to date, but that's not always easy to do. It takes time. There's a lot of work goes into these things on a weekly basis. I hope that answers the question.
Are there any more?
The question is how the environmental, product environmental declaration systems are coming to U.S. Is that picking up in the U.S. because it's more European system? Environmental, product environmental declaration systems. EPDs. So EPDs, environmental product declaration. How it is coming to U.S. My question is that picking up in U.S.?
Oh, yes, okay, we're talking about EPDs, absolutely. There are a number of program operators, some of stuff in the CS. So we have that. There's also a consortium form where those program operators are coming together with the ULE is in that, but it's doing its own thing. It's very high and doing turn. So it's doing, so yeah, it's pretty
Is there a
strong.
relation between that and life cycle costing?
They're not the same at all. Environmental product declaration is doing what LCA does. It is not measuring the cost. Okay?
I have a question for you.
Okay.
How many buildings have done this process in the United States that you're aware of?
Well, the process has been going on for quite a long time now, almost 20 years. And a lot of design teams are doing it almost just as a part of their process. Like one of the tools up there, the Athena tool, is free. Design teams can download it, and you know the amount of information coming in back into that association, not-for-profit association, is just kind of constant. So I don't have a number in hand, but it's hundreds for sure, if not more, because it's become a very common thing to do. Even if, well, partly because of the lead rating system, but even if it's not, you know, they're not interested in that aspect, it helps design teams sort through what they should do. So.
And one final question. Does this type of design approaches have a peer review like an EPD does on the system?
In that standard, the 2921 standard, it has some requirements, and one is the reporting and what must be in the reporting. And then I'm not sure if the IGCC has a requirement for that to be reviewed, but E2921 does say that it should be reviewed by, I can't remember now whether it are certified, not certified in a legal sense, but approved by a senior person involved in the design team. So then if something is found that's wrong, well, then they're going to be blamed.
Well, thank you, Wayne. No more questions? Thank you very much.
Thank you.